Happy. Okay, so one question that comes to mind, and this might just be a limitation or a kind of a factor of the way the stack works, but in your more complicated example of 3 digits that you're adding together, can you not do 3 digits on the stack and then like a plus plus, or is that not possible?
Yeah, you could. It just depends what kind of basic operations you want to have. I mean, I've chosen a very simple stack machine here, which just has pushing a number onto the stack and then adding 2 numbers onto the stack. But you could have a generalized addition that took any number of parameters off the stack, and that'd be quite fine. I mean, that's the kind of thing, if you wanted to optimize your code, you might have other instructions like that one.
Where does this sort of thing get used in the real world then? Where does this get applied?
Well, that's a really good question. So, I mean, there's the gold standard for compiler correctness is having a real compiler and actually doing a proper mathematical proof that it is actually fully correct. And that has actually been done. There's a fully optimizing production quality C compiler, which is purely, which has been completely formally verified using a mechanical proof assistant, and that's kind of the gold standard. But that's kind of 10 person years of effort to do something like that. It's not something you can do in a 15-minute little video. But the idea of program correctness is something which is hugely important in the computing industry. In the hardware industry, they do tend to now formally prove the correctness of their hardware, because if you ship a Pentium processor and it's got a bug in it, it's going to cost you an awful lot of money to replace those. And there's various horror stories about chips that have had to be replaced. I mean, this is the famous Pentium floating point division bug, which cost Intel about $500 million to recall various chips. And after things like that happened, they started to get very interested in formal verification. So hardware correctness is something which is very, very important in the hardware industry, and they do use formal mathematical proofs as a matter of course these days because it's so expensive. It's starting to come in the software industry. I mean, something like Quick Check, for example, is very widely used. I mean, it's not a formal proof, but it gives you high confidence, and Quick Check exists for any programming language. So some of these kind of lightweight methods for kind of getting higher confidence and correctness are becoming very important. But some military applications, I mean, they do demand full formal mathematical proofs. Same for some medical applications as well. I mean, if you're wired up to a heart bypass machine, maybe you'd like to know that the software in that has been formally proved correct mathematically.